Good morning. I guess we'll get started. My name's Darren Woods. I'm the Director of Aroostook County Emergency Management. And this is Maureen Hastings. She's a hydrologist for the National Weather Service in Caribou. And I had asked Maureen if she could help us out with a little bit of training on river ice and things like that and what to look for. We know we're a little early in the season, but as it gets going, we get very busy, so we figured maybe we could start doing some outreach now. We have been getting some folks participating online, and that is the case again today. That's what that other computer setup is, and these mics everywhere is for. And I am also recording this so that if somebody wants it for their local access channel, that we can provide that for the citizens to look at. With that, I'll just turn it right over to Maureen and let you get going.
All right, good morning, everyone. Yes, we are a little early. I know you don't necessarily want to be thinking about winter and spring breakup just yet, but I did hear they had flurries in Bangor this morning, so winter is coming. Nice. Better than us. So I am the hydrology program manager and a general forecaster for the National Weather Service in Caribou. And just a little bit about myself. I have been at the Caribou office for almost 4 years. It'll be 4 years in January. And prior to Caribou, I worked for the National Weather Service office in Burlington, Vermont. That was for 7 years. So I have been in the North Country for a little while now. So we will just get right into it. So river ice kind of forms different ways depending on whether you have a fast-moving river or a slow-moving river. And we'll talk about fast-moving rivers first. It's a little more complicated when it comes to fast-moving rivers. So it all begins with the formation of frazzle ice. What is frazzle ice? That's frazzle ice. It's that slushy stuff you see right early in the season. So what happens is you have little ice crystals or ice particles in the atmosphere get kind of entrained into the river, into the water. The water has to be super cool. Now, super cool means it's actually just below freezing, so it's like 31 degrees, 31.5 degrees, something like that. So as soon as those ice particles get entrained into the water, they're going to freeze, basically freeze on contact. Your frazzle ice is obviously very common early in your season, but you can see frazzle production right through winter. And how much frazzle ice you have depends on how big of an open area of water that you have on your waterway, as well as your rate of heat loss. So your rate of heat from the water going into the atmosphere. So what happens is once you get the frazzle particles to form, they start sticking together in that water. They adhere together, and they're going to form what can be called clusters, flocks. Sometimes you'll see them called discs. And those generally are going to be buoyant because there's a lot of air. So they'll float up to the surface. And once they're at the surface, they just start to, again, stick to each other and kind of grow bigger and bigger. And they will form what's called ice pans, or I've heard it called pancake ice. So these pans will just kind of float along the top of your river until it gets to some place where either the flow slows or it reaches an obstruction, maybe existing ice cover. It'll end up, the frazzle ice, the pans will just collect on that obstruction. This is what that looks like. So there's some ice pans there. So those will just float along as long as they're free to move until either they come to an obstruction or some kind of place where the river flow slows. So as we continue to head into winter and it gets colder, you lose more of the heat from the water to the atmosphere. You're going to get, the ice pans are just going to freeze into a solid surface along your river top there. Now the frazzle isn't necessarily all going to float to the top. It may stay in that flow, and if it encounters a place where, especially if your bed of your river becomes from steep to relatively flat or relatively shallow, if there's an existing ice cover here, that frazzle can collect on the leading edge of that ice cover, and that's called a hanging dam. Now hanging dams can cause a lot of problems because obviously it causes your ice cover to become very thick, so you can actually get a significant amount of blockage. So we can actually see a fair amount of flooding from a hanging dam. So if you have a fast-moving shallow river, that frazzle can actually stick to the riverbed, so to the rocks or to the gravel or whatever your riverbed is made up of. And this is called anchor ice. Now anchor ice generally is going to form in the evening when you're getting your greatest cooling of your water. And this too can cause a significant blockage. And I'll show some pictures here in a little bit of what anchor ice can do. But really, other than this little bit, we don't know a lot about anchor ice. It's something that's still under study, exactly how it forms and why it forms where it does. And this is what anchor ice looks like. So you can see it's just ice that's collected on the rocks there in this shallow waterway. So this graphic just shows everything I just talked about. So basically going from left to right, you've got your ice crystals from the air being entrained into your water, which is super cooled, so they're going to freeze on contact. They grow into discs as they accumulate. Some of those discs are going to rise to the surface and move down your waterway until they encounter maybe some stable ice cover. Any frazzle that stays in your water is going to just continue to move downstream. Some could create a hanging dam. Some could collect on the bottom to create anchor ice. And some is just going to stay in the water and just move underneath that ice cover, maybe collect somewhere downstream. So this is kind of the basics for ice formation in fast-moving rivers. Slow-moving rivers are it's a lot simpler process. So basically what happens is, again, your water becomes super cooled, it's just below freezing. You're going to get ice crystals that form right along the water surface. It's just a skim of ice. And once that ice sheet develops, it just begins to grow downward at that ice-water interface. It just slowly continues to grow through the season. Now once you have a pretty decent ice cover, that'll actually slow your heat loss, so it'll help kind of insulate that water from losing any more heat. And if you've ever heard of black or blue ice, that's how this forms, is by growing downward. And this is what sheet ice looks like. So it's very uniform, very flat, and it's usually very, very strong ice cover. This is the Mattawamkeag at Mattawamkeag, looking down towards the Penobscot. Alright, so there's a couple of different types of ice crystal structures. The first is your fine-grained ice, and that's the frazzle that we talked about. So this is going to be more of your turbulent, your faster-moving rivers is going to have this kind of ice. A lot of times it's called white ice because it's more opaque, and that's because it's got a lot of air pockets in it. So because it's got a lot of air pockets in it, it's also weaker and it's a lot less dense than your second type of ice, which is columnar ice. It can also be called candle ice. This is the thermally grown, so this is that slower moving river that I talked about, where you get the thin sheet of ice and then it gradually grows downward. And this is a lot more solid and harder to break up than your white ice. So here's a good example of your white versus black ice. This is an ice jam that developed this past January on the Piscataquis River near Medford. And you can see at the top there, what probably happened is early in the season, it had frazzle that floated to the top, created pans, became a solid ice sheet. So it's really white. You can see it's opaque. There's going to be a lot of air in that ice. But once that frazzle ice had froze and had a solid ice cover, and you can see that second layer there, that black ice, what probably happened is it froze downward towards the riverbed as the winter went on and the water got colder. So again, that white ice is going to be less dense and weaker than that black ice. And you can see that black ice is actually pretty clear. Now what makes black ice so strong is its crystal structure, and this is called candle ice. So basically what happens is when that ice begins to grow downward, it forms these columnar or tubular type structures you can see here. It's called candle ice. Now it can be hard to see until you actually get into spring and your ice starts to melt a little bit, because it'll melt first along the edges where the crystals meet, and that's when you can start to see these candle structures here. But it's a very rigid, very strong type of crystal setup. So that's what makes your black ice so very strong, is that crystal structure. So what is an ice jam? Well, it's any accumulation of ice that's going to affect your river flow. So it either maybe causes a backup, water to back up until you get flooding upstream, or maybe it reduces your flow downstream, so it affects downstream. So any kind of accumulation of ice that causes changes in river flow is what we classify as an ice jam. There's a few different types of ice jams. There's a freeze up, break up, and a combination. And then we've already discussed a little bit about the two special circumstances, the hanging dam and the anchor ice, and I'll discuss those a little bit further. So freeze-up jams are primarily frazzle ice. They form early in the winter, so right as we start to really get to the cold weather. Again, you get your frazzle ice that forms into pans, and then as it's floating on the surface, it's going to slow or stop. Any place where it's going to reach a place that the river slope changes or slows. So a reduction in the water slope, some kind of obstruction, those kinds of things. And what happens is your frazzle starts to, it kind of starts to slow along the edges first. So it'll arch across the surface of your river, and that's how your freeze-up jam will develop. Now, freeze-up jams generally occur when we get our first really cold stretch of weather in the winter. So you need really cold air, really cold water. You need a fairly steady state of your river flow, so no sudden increases or decreases. And you need a real consolidated top layer of your water. And freeze-up jams generally don't cause too many flooding problems. They're not, enough that we kind of keep an eye on and know where they are, but they generally don't cause us any problems. So here's a cross-section of what a freeze-up jam looks like. And you can see it's actually fairly stratified, but each layer there is somewhat uniform. You've got your frazzle on the top that most likely froze up first, and then at your you've got a surface layer that's refrozen at that ice-water interface, and then underneath that you get more frazzle, maybe some more ice chunks that kind of collect underneath that top layer. So you can see it does reduce your area of where your water is going to be able to move through, but again, it generally doesn't cause us too many problems. And this is what a freeze-up jam looks like. So you can actually see the pans that have kind of come together and have just kind of accumulated here, probably because of the bend of the river is why this jam has formed in this particular location. So it's very rough looking, but you can kind of see the pans have kind of formed together there. Now, breakup jams, of course, are our biggest concern. They are what occur during periods of thaw, usually in mid-spring. These are going to be your ice chunks, your big ice blocks. That's usually going to be associated with some kind of rapid increase in discharge or river flow, so a heavy rainfall event, a lot of snow melt, maybe a release from a dam, those kinds of things. And generally, the later you go into the season for breakup, it's going to be accelerated by warmer temperatures and a stronger sun. This is what happened this past spring, in that we stayed cold very late into the spring, later than normal. So we kept a really deep snowpack. Our ice cover was very strong. It didn't have a chance to really melt as we headed into spring. So when we finally warmed up, it warmed up in a hurry. We already had a pretty strong sun, so we had lots of snow melt. And that ice, when it broke up, was still relatively strong. So that's why we had a lot of problems this past spring. Not completely the scenario we don't like to see during breakups. So what happens is once your ice cover breaks up, the broken pieces will just move downstream, just like the frazzle ice. Will just move downstream until they encounter some kind of obstruction or some kind of place where your flow is going to slow. And And that point where it starts to collect is called your jam initiation point. And once the first pieces kind of stop moving, they start to collect, and then you just get more and more behind it. So that's how you get your jam. This is what a breakup jam looks like. As you can see, it's a lot more chaotic than your freeze-up jam. And you've got your big ice chunks, but then in between you'll get maybe smaller chunks, or chunks that started out big and have been tumbled over and over and they're kind of broken up. And it actually can make a very solid jam, which is part of the reason why it's very strong. It's hard for it to move once it gets lodged in there. So, and obviously the longer it sits there, the more flooding potentially you have. And this is what a breakup jam looks like. So you can see the big chunks that are broken up there. This is the Caribou River in Bangor this past spring. That's where this picture is taken. So how big your jam is, how severe your jam is, depends on 4 things. Your flow conditions. So basically, kind of the thought is the higher your flow, the hope that it'll help just push that ice out of there. How much ice you have upstream. So if you have more ice upstream, obviously that means your jam can just grow and grow and grow. How big and how strong your ice pieces are. So if you have very, very thick ice cover that breaks up, they're going to be very strong and very hard to dislodge once they jam up. And then the characteristics of your flood area. So we'll get into this a little bit more, but what kind of floodplain is it? Is it natural? Has it been altered by people? Like in Bangor there, for example, they've taken the channel where it goes through downtown and made it concrete, versus maybe a natural river that's got natural rock or grass or those kinds of things. So all that can depend on what happens with your jam. Now we can get jams in the middle part of winter. We all know about January thaws, and this is what actually happened this past spring, or this past winter, is downstate. We got a really strong thaw and a bunch of rain, and at least in the northern part of the county, you just turned to ice, but more downstate, they actually saw rivers break up. So it can happen. And so usually what happens is, so your rivers will come up, because let's say against snow melt or a heavy rain event, your ice breaks up, it collects someplace, and it jams up. Well, then it gets cold again. So your river level drops, and your ice is going to drop. And it can actually become embedded or sit down on the river bottom. And just like an anchor, once it gets lodged in there, that makes it harder to move come spring. So these are things that we look for as we head into the spring breakup, is anywhere maybe we had a breakup midwinter. Like the picture I showed earlier of the jam on the Scottish River with the white and black ice. That was something we watched very closely. It broke up in January and then sat there all winter, and then so when it broke up in the spring, we watched very, very closely to make sure we didn't have any problems there. So that is something to look for. Now combination jams are basically any kind of jam that's some kind of mixture of freeze up and break up. There's no set formula per se. But let's say you get a freeze up jam that forms early in the season and doesn't cause any problems, but then maybe through the winter, that frazzle ice that's going underneath the ice can kind of collect in that jam. So maybe it makes a bigger jam through the winter. Or during the spring breakup, maybe it breaks up with the rest of the ice, and then you have that much more ice cover to collect somewhere else downstream and cause a breakup jam. So it's basically any kind of jam that's not straight freeze up or straight breakup. And again, usually this kind of jam, it's going to be thicker than regular sheet ice, so you're going to have a lot more ice available to jam someplace downstream. The hanging dams we talked about a little bit already, and that's where your frazzle collects underneath existing ice cover. It can be many times thicker than the surrounding sheet ice, and therefore is harder and slower to break up in the spring. It can provide a potential point, an initiation point for a breakup jam later in the season, or it can break up with the rest of the ice cover, and again, then have that much more ice that's available for jamming someplace else downstream. And we can kind of, they're hard to see, obviously, they're under the ice. We can kind of maybe guess where they might be, but we don't know, obviously don't know for sure. And anchor ice, which again I already discussed a little bit, That's where your fragile ice collects on the riverbed, on your shallow, turbulent rivers. And what it does is it just grows upward as the winter progresses. So that water just gets lifted upward. You think it's got to go somewhere, it just gets lifted upward by that ice. Now this ice, because it's a shallow river, as we head into spring and the sun angle gets stronger, it does tend to kind of weaken a little bit and get dislodged. But then again, then you've got more ice to move downstream to potentially cause problems elsewhere. So we're going to see what anchor ice can do. This is a stream in Montana, I believe. So you can see it's just a river here that goes through this little park. And we're going to keep our eye on that picnic shelter there. That's that same shelter. So this is flooding completely due to anchor ice. And you can see that luckily it's just a park, because if there was homes or something there, they would be flooding. So anchor ice can be kind of sneaky. You know, you might just discount it a little bit, but it can actually do a fair amount of flooding. So something to kind of keep your eye on. So what causes an ice jam? You know, what causes the ice to break up? And once it breaks up, what causes it to collect where it does? So some common factors here. Your river geometries, or the shape of your river. So again, a big one is your river slope, or anywhere where your flow decreases. A confluence, where you have a smaller river going into a larger river. Sharp bends and constrictions. We also have a set number of some weather characteristics that we look for heading into breakup. Thawing temperatures, snow melt, heavy rain, and the time of season can also dictate what kind of jam you're going to have. And then floodplain land use practices. Again, what's been done to that floodplain, what's been done to that river channel can have an effect on what kind of jam you're going to see. So the easiest way to kind of get your head around how ice reacts in a river once it's broken up is think about driving down I-95, going down to Portland or something, and you're just, you know, if it's 3 lanes and everybody's going 70 miles an hour, same speed, no problem, right? Just smooth sailing. But once somebody slows down, let's say they miss their exit, or they see a deer on the side of the road, or something like that, what happens? Everybody behind them slows down, and you get a traffic jam. And this is the same way that ice works. So anywhere where you're going to see the river flow slow down is where you're going to have a problem. And what it's called is the river exceeds its transport capacity, is the phrasing we use. That means it just gets to where it can't carry that much ice anymore. And a lot of times when this happens is where the river, the slope changes from steep to mild. And it can be very subtle. It doesn't take much, but it just levels out just a little bit. And one way to see where this happens is where there's islands. Islands or gravel bars or sandbars, something like that. Because just like in the spring with ice, through the summer, you know, the river's carrying sand and silt and things that get washed into the water. Well, just like with ice, it gets to a point where it can't carry all that sand anymore because its flow slows down, so it deposits it on the riverbed, and after hundreds of years, you get an island. So a lot of times people think islands or sandbars cause ice jams. That's not necessarily true. It just is a good indicator of where that flow is slowing down and where you might get ice to collect in the spring. So let's look at a little example here. This is the St. John near Madawaska. And this is this past spring. And you can see there's a lot of ice just kind of floating through the river there. It's not having a problem, just like an I-95. Everybody's going the same speed. It's just floating through. And maybe the river is fairly deep here. It's probably a little bit narrow, so that the flow is a little faster. So it's just, you know, not causing any kind of problems. Let's go a couple miles downstream. We've got ice collecting. So the first thing I see, there's an island there. There's an island there. So this is someplace where the water flowing from left to right is slowing down. And you can see, again, even in the summer, it's been depositing sand and dirt here because the flow is slowing down. So accordingly, as that ice moved downstream, it has also slowed down and started to jam up here. So that is something that, again, that we can kind of key on to know, okay, in the spring this might be a place we need to watch for a potential ice jam. This is the Penobscot River near Wynn. Again, this was this past spring. Just like, again, using the interstate example, if you go from 3 lanes down to 1 lane, what happens? Back up, backlog. This is the same thing that's happened here. So the river's gone from somewhat wide to somewhat narrow. It's kind of going around those bends there. So the ice is just jammed up there. Just can't all make it through at once. So another something else we look for a potential problem spot for where we might see an ice jam. Now, a lot of times we see ice jams develop somewhere where a smaller river goes into a larger river. And what happens is those smaller rivers are going to respond to rainfall or runoff a lot faster than your larger river is. So the ice is going to break up on those smaller rivers first. So the ice breaks up in that smaller river, floats downstream. Well, it gets to the larger river and it can't go anywhere. That larger river's got a stronger intact ice cover, so that the ice from the smaller river collects on that larger, that existing ice cover, jams up, and then causes flooding upstream on that smaller river. So this is another common place where we can see problems. Now there's some weather characteristics and things that we look for heading into spring to let us know that maybe we've got a chance of breakup coming. Sustained thawing temperatures, meaning temperatures above 32 degrees, snow melt, heavy rain, and again, the time of season can also play a role. So, sustained thawing temperatures. This is kind of a rule that tends to work a little bit better in southern areas, because ice is generally a little too thick up here. But depending on a wide range of preceding conditions, several days of temperatures around 40 degrees, or even just several hours of temperatures around 60 degrees, can be enough to allow river ice to break up and jam. Kind of a general rule of thumb is 240 accumulated thawing degree hours. So this is how many hours your temperature is above 32 degrees and how much above 32 degrees it is. So for example, for the ice to break up in one day, your average daily temperature, which your daily temperature is your high temperature and your low temperature added together, divided by 2. So if your average daily temperature is at least 42 degrees for one day, you can get the ice to break up in one day. For 2 days, you need daily temperatures to be around 37 degrees. So again, this tends to work a little bit better downstate, but kind of a general rule of thumb, and we know we're coming into maybe a short period of thaw, is to kind of look and see if we think it's going to be warm enough, long enough to get that 240 thawing degree hours. Now usually for us here, it's going to be more snowmelt runoff and heavy rain that's going to cause our ice to move. As we know, we can have a lot of snow here as we head into spring. That's what happened this past year. And we can have a foot of liquid in that snowpack. That's called snow water equivalent. And if you just think, if we melt that very quickly, we warm up all of a sudden to 70 degrees for a few days, all that water is going to go at once, and it's got to go somewhere, and it goes into the rivers. So what happens is then it causes the rivers to rise. Eventually they get to where the flow is strong enough to lift that river ice and break it up. And heavy rain can only exacerbate this problem. It's going to ripen your snowpack, meaning it's going to add to its water content and bring it closer to that melting temperature. And it just adds to that volume of water moving into area rivers. So kind of a rule of thumb we like to use is river rises of 1.5 to 3 times the thickness of river ice is enough to cause the ice to lift and move and perhaps jam someplace downstream. Generally, you need your ice to be around a foot thick to be strong enough to really cause problems. Usually if it's 10 inches or less, not that it won't jam up somewhere, but it's weak enough that it'll just eventually get pushed out with no problems. Usually you need at least a foot or more. to really be strong enough to really jam up hard and then cause flooding. Now the U.S. Geological Survey, they're the ones that measure ice thickness. They actually go out and drill a hole in the ice and measure how thick it is. They're kind of on a 3 to 4 week rotation through the winter. They're just going around the entire state measuring the rivers on how much ice. And in between those times of measurement, the ice thickness can actually be estimated using a very rough equation, which I keep track of at my office. But it basically uses the same kind of idea with accumulated thawing degree hours. But then we also look at what kind of waterway is it. Is it a lake, with very little flow? Is it a slow-moving river? Is it a fast-moving river? Those kinds of things. So it's not an exact science, but it estimates pretty well. So as an example from this past spring, we'll look at some different river ice thicknesses here. So let's see. Here's Masardis, Aroostook River at Masardis. So it was estimated to be around 30 inches thick, April 2nd. And these numbers are all above normal for April 2nd. So using that 1.5 to 3 times rule, we need at least 3.5 feet of rise on that river to break that ice up, and at most 7.5. So again, heading into a potential melt or a thaw, we'll look at the river predictions and see, okay, are we going to get rises of that much in that range? Okay, we are. So we're on the lookout for breakup. And yes, river ice can be very, very thick here. So that's yardstick, so it's around 3 feet, and that ice is thicker than that. And I know this past spring we had ice that was 3 to 4 feet thick in some places. So it can be very, very thick around here. So time of season can also play a role on what kind of breakup you're going to have. Generally, as you head into early spring, your ice is going to be stronger than mid to late spring. As I'm sure you guys know, anything that's a light color reflects sunlight. Anything that's a darker color is going to absorb sunlight. So as we head into spring, if you can get that snow to melt off the ice cover, if you can get water to collect on that ice cover, that darkens the surface color. So that allows it to absorb more of that sun's heat, and it'll actually start to melt it from the top. If you have an open area of the river, again, water is a dark color, so that water can maybe absorb a little of that sun's heat, and then it can melt the ice from the bottom. So we actually like to see in the spring, we like the snow to melt, at least on the ice surface itself. We like to see water on top of it, because that's helping to melt that ice from the top and weaken it. The more it can weaken before it breaks up, the better. Now, any kind of man-made or even nature-made obstruction can cause issues with ice jams. Any kind of bridge that goes across the river, around here they're usually pretty cognizant, obviously, of ice jam issues, so they're not gonna develop something that's going to be a problem. But a small culvert or a very shallow bridge can be a problem. Any kind of fallen trees, again, sand and gravel bars, islands, they might not cause a jam, but they can make it worse. And any kind of structural changes in your river and reservoir regulation. So if you've got a dam that's releasing water or holding back water, any of those kinds of things can affect what kind of ice jam or ice jam season you're going to have.
We do have a lot of issues in the county with trees down, blocking culverts, especially on the back roads that aren't maintained quite as well. You might have beaver causing issues, or just the fact that the culverts haven't been cleaned out before everything froze up. Those are all the issues you'll deal with come spring.
We have a lot of roads that flood every year, but last year was particularly bad with ice jams, especially near Dye Brook.
Yeah, it was a bad. I know for northern Aroostook County, it was probably the worst flooding we've had in 20 years. So it was a bad. We knew going in. Again, the ice was very thick. Things froze up very early, and then it stayed really cold all winter. So
one of the contributing factors last year was the fact that we had the temperature rise, and we had a lot of snow. She was talking earlier about, you know, the runoff, and so we not only had some additional issues with flooding because we had all that extra water running into the streams, but we also had fields opening up and causing issues, flooding roads where we don't typically flood. It's just the way that it happened to melt off.
Again, if you hold that snowpack late into the season, and the longer it stays cold, and the longer you keep that snowpack, chances are when you finally warm up, you're going to warm up in a hurry, and then it all goes at once. So, yeah, and then if the ground's still frozen, that water can't seep into the ground. It's just got to run off, and we did have a lot of problems with roads closed just due to field flooding, really, just stuff flowing out of the fields.
Most of our road closures were field flooding.
Right.
I think in 2006 or 2007 we had to evacuate a lot of homes.
It was 2008.
2008, was it that late?
Yeah.
Yeah, we had to evacuate a lot of homes, and last year people just left their homes on their own because they flooded.
Excellent.
We have a lot of issues with that.
Now dams are kind of a mixed blessing, I guess. In some ways, having a dam on a river can actually be a good thing. It can provide, the pool behind the dam can provide storage for ice. So the ice can break up, you know, upstream can break up and come downriver, and then it just collects in that pool. It doesn't cause a problem. Whereas maybe if that dam wasn't there, it would jam up someplace downstream. But you know, also if you think that pool, maybe the ice is stronger on that pool, which like would be on a lake. So it breaks up late. And if you get ice that breaks up upstream, then it moves downstream, and it'll collect on that pool and then cause jamming upstream. So they're kind of a mixed blessing. But you know, really the bottom line is anywhere that's favorable for ice jams, you know, or where there are islands or gravel bars, you know, humans kind of tend to favor those places as well to build bridges and dams and things. So there's this really kind of mixed, complex relationship between what men do and what nature does, and how it all interacts together. It really affects your ice cover and your ice jam season. So when it comes to actually breaking up the ice, there's a couple different methods. Thermal breakup is where the ice cover just sits and melts in place. Again, as you head into spring, your sun gets stronger, so it's able to melt that ice. If the snow is gone from the ice surface, you can melt that ice. If there's water on the ice, that'll help melt it. And this kind of breakup, this thermal breakup, is a lot less likely to cause a problem. This is the kind of season we had in spring of 2013. And what happened there was we didn't have any big rainfall events. We were dry in the spring, so no heavy precipitation to cause the rivers to rise. And temperatures were perfect. It was above freezing during the day, so allowing a little bit of snow melt, but then it would drop back below freezing at night, so the snow melt would slow. So it really tempered that snow melt. It didn't happen all at once. This is ideal. We were very happy. And I'm sure a lot of you were happy too, because I know a lot of the locals up there in Northern County who have been there for 50, 60, 70 years, and it was the easiest ice out they had ever seen. So it was perfect. Unfortunately, this spring, then it was bad. So mechanical breakup is the type of breakup that causes issues. And that's where, again, your river rises, it's going to be due to heavy rain or a lot of snow melt. And what happens is that river just rises, the flow increases, and it finally gets to the point where it's strong enough to lift that ice cover and move it and cause it to break up and then potentially jam somewhere. Again, we kind of use a rough guide of 1.5 to 3 times the ice cover thickness. That's what's needed to lift and break it up. And this type of breakup is obviously a lot more favorable for green ice jams. So let's do a quick little example here. So April 12th, 2014, I was out making a river ice tour, like I do oftentimes in the spring. So let's see, where do we think the ice is going to break up first? All right, so this is the St. John River near Hamlin, which is near Van Buren. What would you guys say about this ice cover? Does it look strong? Does it look weak? Does it look solid? Does it look... Yeah, I'd say it's still very strong. It's still got a little bit of snow on top there. I don't see water on top, so it's not melting. It's pretty, it's one solid sheet of ice, and that color kind of makes me think it's probably black ice, so it's going to be very, very strong. So probably still a little ways from breakup for this stretch of the river. So let's move upstream. This is near Fort Kent. What can you guys tell me about this ice?
Weaker.
Yep, weaker, exactly. You've got some water collecting on the ice there. You might even maybe see, maybe an open area right there, maybe. This ice is going to be weaker. So let's go even further upstream to Dickey Bridge, St. John River at Dickey Bridge. This is by Allagash. What do you guys think about this ice?
Ready to go.
Looks pretty rotten, right? Yep, ready to go, exactly. So, where do you think the ice is going to break up first?
Right there.
Right there, okay? Why do we think that might be a problem?
Because it's solid down below, so it's going to be.
Exactly, exactly. And sure enough, a week later, it's exactly what happened. So this is down by Van Buren where that stronger ice cover was. And you can see, ice has moved in, again from the left to right, and jammed up on that solid ice cover. So that's exactly what happened. So I'm out March and April, I'm out at least on the road at least 2 times a week, usually 1 to 2 times a week. And this is the kind of stuff I'm looking for. What's the ice cover look like? Is it still really solid? Is it starting to rot? Is it, is there a place where you put like this, where it's solid downstream and weakening upstream, where there might be a problem? Usually the kinds of things I'm looking for. So then we know, okay, when it finally does break up, we might have issues in this location. Okay, so once the ice starts breaking up, now what? Well, again, those pieces are just going to move downstream until that transport capacity is exceeded. Again, anywhere where your river flow slows, decrease in slope, lose in obstruction. Jams can form very, very quickly, very, very suddenly. Upstream of that jam, you may get a lot of flooding as the water backs up. If the jam releases or ultimately fails, you may actually get a downstream surge, which may cause a lot of flooding. It can actually erode your riverbed. Ice is very rough, and you can see, especially if that ice is still 3 or 4 feet thick, it's going to be very, very powerful. So it can change the way your river flows. It can erode structures. It can do all kinds of stuff. So lots of problems. So the flooding upstream of the jam can flood very, very quickly. This is a picture from Alaska. The river is flowing from bottom right there to top left. And you can see we've got an ice jam here on this river. One thing I noticed, big island, so what does that tell you? The river slows there. So you know there's going to be a problem. So indeed, the ice is jammed up right around this corner here. So what's happened is the water is moving around that jam and flowing into the surrounding countryside here. So this is the topographical map of that same area. So there's that big island right there. So we were looking at this bend here. That's where the ice jam is. Here's where that water was flowing around the jam. So we had some roads washed out. And one thing I noticed was we got this little tributary here that was flowing into the big river. It flooded too, because it was trying to send water into this river and it couldn't go anywhere, so it backed up too. So ice jams don't affect just the immediate area. They can affect anywhere upstream, they can affect anywhere downstream. But any smaller rivers like this, they can get backed up too and cause problems even further upstream.
In 2008, in Fort Kent, that's what happened. That very similar setup. This area, or that area, that tributary. Can you point to that again?
This?
Yeah, right there. Kind of goes right through the center of Fort Kent. So St. John River, while it was rising, it never did come up over the top of the dike. What happened was that stream that goes right through the center of town backfed and everything backed up into that, and that came up over the road, and that's actually what flooded 410.
So,
But we were on the edge of it getting much, much worse.
so this is just those homes that were flooded by that jam. It's the homes that got flooded here. So the ice itself in the water, causes problems, but the ice pieces themselves can actually be carried out of the river channel. Here's a picture from Wade, Maine. It's by Washburn. This is actually the road I live on, so it's just on the road for me. You can see the ice pieces have actually gone onto the road there. So even once the water recedes, they're going to have to send out some kind of heavy equipment to remove that ice and open the road. And when I was in Vermont, there's one time I was out looking at ice jams, and they had ice piled this high on the roadway, so 5 feet tall, that they did have to come out and remove. So there's Crouseville, so you can see a lot of ice where it doesn't belong. It's damaged this fence here. And here's a picture from Tunbridge, Vermont. Chances are even this house could have been shifted off its foundation. I mean, ice is that strong. And it's going to go where it's going to go. You can't stop it. So hopefully these people were smart and evacuated and told to do so. And hopefully they had insurance. So. Now when an ice jam releases, especially if it's a big jam that's been sitting there a long time, has a lot of water backed up behind it, it's like a dam break. I mean, you're letting that water go all at once. And again, that ice, it can do damage to roadways, it can damage bridge supports, it can change the direction of which way the river flows. And a lot of our older dams, are tested by this river ice regularly. They just removed a little dam in Washburn, Mill Pond Dam, because it was structurally deficient. And maybe it was because, it has to go through this cycle of ice every spring. And finally, just couldn't take it anymore. So let's see. So this is a little stream in central Vermont. This is Fletcher Brook. So you can see a road here that's been closed, been damaged by either water coming across it. Here's a railroad bed that has actually been shoved or bent by the ice coming across it. So, road in Dickey, 92, I think somebody told me.
Yeah, 1992.
You can see it just ate that road bed right away.
That was the year that the bridge was taken up as
right.
well.
Yep. So, and this is that same railroad that we saw. So not only was the railroad, the tracks actually bent, but it's actually washed out underneath the tracks as well. So they've got a lot of repair they're going to have to do before they can run any trains through here. So a little bit about ice jam climatology. So the red areas they've seen 10 or more ice jams. Orange is 5 to 10, and the yellow is 5 or less. So I'm sure you can pick out your favorite spots of where there's been a lot of ice jams, especially more so up north. And one thing I noticed when I went downstate here is there's a lot fewer red markers, so they just get fewer jams down there. And it's likely due to the fact that the ice is probably thinner there once we break up in the spring. The Penobscot River has got a lot of dams on it, so that may have something to do with it too. But so kind of disparity there between northern Maine and southern Maine. So there's a place in Hanover, New Hampshire, the Cold Regions Research and Engineering Laboratory, which is a mouthful to say, so we just call it Corel. They are the ice jam gurus. If I had a question, I knew that. They keep a database of all ice jams that have happened, and this is across the country. Not counting this past spring, there have been 730 ice jams in Maine since 1780. Out of 83 rivers, the St. John was the winner, the 111. The Aroostook was behind with 92. 127 towns. Decay had 57. Washburn had 35. These mostly all ordering spots there. So, and Corel, I do, when I see ice jams out on my trips, I do let them know. I send them an email or give them a call. Let them know I see the ice jams. They can put it. Yes.
Yeah, the 9 Mile Bridge, is that the one in Reed?
Where?
No, that's actually the one that's in very northwestern.
Okay.
Yeah, that's way upstream. It's like at the headwaters of the St. John.
Okay.
So. And when, obviously March and April are when we get most of our ice jams. That's obviously during spring breakup. But midwinter, in January, February, December, we can get jams then too. And some of these might be freeze-up jams, but some are probably jams when we've had a midwinter thaw, a January thaw. And again, this happened this past January. We had rivers downstate that broke up and jammed up. So it can happen any time during cold season, really. So some services that we at the National Weather Service provide. This is our website. Who is familiar with our website? Anyone? Has anybody ever used it? It has changed recently over the past few months. We have changed to a different site. There's a lot of information on this site. I highly recommend just going here and just clicking around and see what you can find. If you're looking for something specific and you can't find it, you can always call us at the office and we can usually walk you through to get to it, but there's a lot of information here. Any kind of watches or warnings, any kind of products that we have issued. Obviously, our regular 7-day forecast is on there. Our forecast discussion is on there, so you can see what we're thinking or what we're looking at down the road. It's a great place to find lots and lots of information. So if you click on the Rivers and Lakes link there, that takes you to our AHAPS page, the Advanced Hydrologic Prediction Service. How many people have used this page before? No one? All right. So the green icons there are anywhere where we've got a river gauge that we monitor. Now the river gauges themselves are actually owned, maintained, and operated by the U.S. Geological Survey, the USGS. So we work very closely in conjunction with them that they kindly allow us to use their data. And we use their data to monitor what the rivers are doing, because when the river's going to flood, we're the ones that issue the flood warnings. So it's their equipment, but we use all their data. And then what happens is if you click on one of those icons.
This is a site that my office uses in those springtime areas. We'll get on there 2-3 times a day and print off those charts so we can compare.
Right.
What the prediction was with what actually happened, and then we can kind of try to get ahead of the curve as much as we can.
Right.
To try to pass out warnings to you folks.
Right.
Things are going on.
So if you click on one of those icons, you get the graph that Darren was talking about. It's called a hydrograph. And so basically, the bottom axis is your date and time. On the left axis is your stage, or your height of your river. Then on the right is your flow in cubic feet per second. Well, thousands of cubic feet per second. Now the thing is the Weather Service, we use stage, so we always talk about feet. The USGS uses flow, and some dam operators and those kinds of things use flow too. That's why there's both on there. So the blue trace is what the river has been doing the past few days. And then the purple trace is what it is forecasted to do. Now, the river forecasts are done by our Northeast River Forecast Center, which is in Taunton, Massachusetts, which is down near Boston. They do our forecasting for us. And basically what happens is they send their forecast to us. We look at it. If we think there's something wrong, we'll give them a call and say, can you look at that again? But usually it's pretty good. And then we send it out so it goes onto this web page. Now they do not take ice into account during the wintertime. So if you ever look at these forecasts in the winter, and your trace is way up here, and the forecast is way down here, that's why. Sometimes, if there's not a lot going on, we'll bump them up so they match, but they don't take ice into account. So that's, if you ever see a big disparity, that's why. It's kind of frustrating that their models won't do that. So some things we look at on these hydrographs to let us know kind of what's going on the rivers. We can't be looking at the rivers all the time. We call Darren and Jesse and are in close contact with them or the towns to see what's going on. But we use these river gauges a lot to kind of see what's going on with our ice out. So this is from Allagash this past spring. I know it's kind of hard to see. So you've got your river. It's getting your river's going up and up and up. Finally gets to the point where it's strong enough to lift that ice cover and break it up. So it lifts it, breaks it up, and oh, it jammed. See how quickly that spiked? And the jam there. It jammed up for a little while, and then the jam moved and released, and the water level dropped back down. And then you went back up and up and up and up. Oh, here's a little jam there. Another big jam here. So you can see how quickly that water rises. And we're talking, each one of these dots is 15 minutes. So, and we're looking at 6, 8, 10, 12 feet, 14 feet. So it goes feet in just minutes. It's very, very quick. Here is a slow release jam. And this is on the Little Madawaska River in Caribou. And so it's going up here and jumped up really fast. And what happened is there's a bridge with a fairly narrow, a road with a fairly narrow culvert underneath it, just downstream of this gauge. And the ice jammed up there. So the ice jammed up, and so the water level rose very, very quickly. Well, then what happened was that ice moved just enough that some of the water could make it through, or the water found a way to get around the jam. So the ice didn't release, the jam was still there, but it just slowly went down, 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 until it got to the point where finally...
I'm sorry. I'm here for bridge, but I guess we're not having it today.
Yes, no, we had booked this firm, so I don't think the bridge was happening today. But I'll bring it into the town office and maybe
I remember now.
So the ice finally got to where it released, and it released very quickly, so the river level dropped, and then we had a little more ice came through, and some rainfall too, so that's what that is. Here is a very fast jam. This is the Aroostook River at Washburn, which seems to jam up this way a lot. So the river level is just going up, 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 and then all of a sudden we get a jam, and it rose very quickly. So there's 10 feet there, and there's, I think that's probably 18 feet or so. So it rose about 8 feet in half an hour. And then the jam flushed out very quickly, so it dropped very quickly. Back to normal. So. Now this is the Piscataqua River at Dover Foxcroft. And you can see here, you've got ice jamming up here, a little jam here, bumped up, and then it released. What do you guys think this big spike is?
Major jam. Major jam.
No.
Maybe it's a dam or something?
No. This is rainfall.
Warmer temperatures out.
We had a heavy rain event. So what happened was with this river, as the ice broke up and it moved out, see how erratic this is? That's very characteristic of ice. and then it got really smooth. See how smooth that is? It's not rough like this. That's just, we had the ice went out, and then we had a heavy rain event after. So that's one way we can tell, again, without having eyes on the river, we can go, okay, look, it dropped, and look how smooth it is. The ice must be out of this river. And we never assume, we'll call somebody who's close by, the police or the fire. If it's in Aroostook County, we'll call Darren or Jesse and say, okay, do you guys know, is the ice falling on out of Van Buren? And they'll say, yep. We'll say, okay, our gauges are right.
That's when we start calling, because, really, there's two of us in my office that can go places. And we try to cover, or we are responsible to cover all of Aroostook County, a little bit of Washington, and a little bit of Comstock County. And, it's just not possible to do it without help. So that's where we start reaching out to you folks for information on, okay, tell us what you see, where you are.
All right, so as we are going through winter, there's a few products that we issue to kind of keep you ahead of the game. How many people know about the spring flood potential outlook? Okay, good. So this is a product that's issued every other week, starting in January, and going through the end of ice out, whenever that occurs. And basically what this is it's a discussion of what the weather conditions have been, what the weather conditions are expected to be for the next 2 weeks, in between the issuances. What the weather conditions are expected to be. Is it going to be warm? Is it going to be cold? Is it going to snow a lot? Is it going to rain? Is it, those kinds of things. And we also talk about what the current snow conditions are. So how much snow is on the ground? How much water is in that snowpack? Is it close to melting? Is it not close to melting? Is it above normal? Is it below normal? And we also talk about river ice conditions. Thick, thin, total ice cover, partial ice cover. Are there any ice jams we're aware of? Trouble spots, those kinds of things. So we use all these factors and we decide for the next 2 weeks, or the next issuance of this product, what is the flood threat? Is it low? Is it high? Is it close to normal? Is it above normal for northern Aroostook County, but for southern Aroostook County it's near normal? These are the things that we look at. So it's a good thing to look at. You can kind of see, okay, they're saying that things are, the snowpack's well above normal, and we're expecting thawing temperatures in the next 2 weeks. So maybe there's a problem. It's a really good way to kind of give you guys a heads up. And all these things are available on our website. And if it's something you can't find, again, call our office and we'll direct you to it. So as we head closer to a potential breakup event, so let's say we see that there's going to be some stretch of warm temperatures, so we think maybe ice is going to break up. We'll issue a flood watch, and that's usually 24 to 48 hours out from the event. And it's just a heads up to, okay, watch out. There's potential that we think the ice could break up and there could be ice jams and flooding. So just again, kind of a heads up, so you kind of know maybe start to prepare. Okay, I need to make sure I have an evacuation plan, or I need to make sure that the equipment out in the backfield is moved, or whatever. So once we actually get into the breakup event, there's a number of products that we issue. The lowest on the rung is the flood advisory, and this is just for really just kind of minor nuisance type flooding. Maybe there's an ice jam, but it's just flooding some fields next to the river, or maybe there's just some culverts that are flowing over the road, or something like that. Usually it's for something that's pretty minor, something that we kind of want to call your attention to, but not anything that's a real significant threat to life or anything like that. And then there's the river flood warning, and we issue that in one of those river forecast points that are our river forecast center down near Boston. And they issue a forecast that brings that river gauge to go above a set flood stage. And we set these flood stages with help from local folks. We set it with help from FEMA and these kinds of agencies that, okay, when the river hits 15 feet, we know this road and this road and this road is going to flood. Or we know when the river hits 20 feet, we know that all of downtown Fort Kent is going to be inundated, or something like that. So these flood stages have been set. So when the forecast, it's either forecast to hit that flood stage or physically goes above that flood stage because of an ice jam or something like that, we'll issue what's called a river flood warning. And you know, to kind of keep in mind is that it's for that gauge that can have effects on either side of that gauge, upstream or downstream. So it's just kind of a way to say, okay, at this river gauge there's flooding. When that gauge floods, this is what happens. So, and these are the river gauges that forecasts are issued for. You can see a few are seasonal, most of year round, and the seasonal ones are generally it's spring thaws when they issue the forecasts. So these are the rivers that you'll see the river forecast flood, the river flood warnings for. A couple other flood products we issue when there's actually ongoing issues. The flash flood warning is kind of our top level warning. That is issued when we're expecting flooding within 6 hours of the causative event. So things like a really heavy thunderstorm or a dam failure or something like that. We generally do not issue flash flood warnings for ice jams because ice jams can be a more longer, drawn-out event. Or they can go very quickly. The exception to that is if it's a really, really extreme event. So, like the flooding they had in 1994 in Fort Fairfield, where a lot of people were in danger, we'll issue a flash flood warning for something like that. It gets people's attention. So if there's a problem and you're having a lot of flooding and people aren't paying attention, we can issue a flash flood warning if you think that'll help people take it seriously. So let us know. Generally for ice jams, we'll issue what's called an aerial flood warning. So a lot of times what we'll do, for example, is let's say Washburn, the Washburn gauge goes over flood. You see it jams up, so there's ice jamming up and moving on the Aroostook River. We'll issue a river flood warning for the Washburn gauge, and then from Washburn all the way downstream through Fort Fairfield, we'll issue an aerial flood warning. Because once that ice moves out, it can jam up anywhere, and it can flood anywhere. So that's how we, get the, Darren and the other emergency managers and the town people to know, okay, the ice is moving, we've got a warning out now, be prepared for flooding. A few other useful websites where you can find some good information. Anybody heard of the Maine Cooperative Snow Survey? No? This is run by MEMA in cooperation with a bunch of other organizations.
This is another product that we use and is sent to your local EMA director. How falls here? Is it Jeremy?
I don't think we found it. Or
Well, by law, you have to have one. So if you don't, then it's automatically Dave, right? Dave's the town manager. Yeah. So he's probably getting this.
I think I get them to Jeremy's reports
Do you?
from him. Yeah.
Okay.
So what this is, it's a collection of agencies that go out, send people out, physically measure the snow, how much snow we've got out there. With the service in Caribou, we've got 11 sites that we go out and measure snow. Now, for a lot of the state, it's only once a month, January and February, because generally it's a hard winter and we're not expecting any kind of problems. Weather service in Caribou, we actually go out every other week, so we've got new information for that winter spring outlook that's issued every other week. But as we get into March, again, through the end of snowmelt season, or through the end of ice out, it's out every week. This is updated. I think it's usually Wednesday. And it's just snow water equivalents, how much water is in your snowpack, how deep the snow is it above normal, is it below normal. It's a good, really good all-around spot to get information. And I like it because somebody has physically gone out and looked at that snow. They've gone out and put a stick in the snow.
We watch it through the winter because, it can kind of give us a clue as to, what our spring might look like, depending on how much snowpack we've got. And then you can click on different products within that. It tells you the water content and how it compares to historical, data that they have. So it kind of helps you out. I mean, it's still all dependent on what the weather does in the spring, how quickly things warm up, and if you have, like Maureen always says, you know, if you have the nice warm days, cold nights, that's the best scenario. You know, it will ease this, but it can kind of give you a look ahead a little bit to give you that preparedness.
If you're heading into, like you did this past spring, if you're heading into a breakup and you know you've got well above normal snowpack, you know, well above normal snow water equivalent, you know you're in trouble. If you're well below normal, then you might be all right. So, one of the sites we measure, the Weather Service measures, is Dyer Brook. I don't know if you've ever seen the little park there, Dyer Brook. We measure snow there. It's one of our sites. So if you ever see a pickup truck sitting out there and somebody put snowshoes on, usually it's me. That's what we're doing, we're just measuring snow. This is the site for the U.S. Geological Survey for their main office. And again, they're the ones that operate and maintain the river gauges across the state. So if you want to get the information direct from the horse's mouth, so to speak, this is a good place to go. There's a lot of other information on this site. There are some river gauges on here that we do not have on our AHAPS page, including some smaller ones I know like near Holton and things. So it's a good place to go to get some of that information. There's groundwater. They've got groundwater wells, water quality, any kind of reservoir or water level information. So there's a lot of information here too. Again, I highly recommend just start clicking around. Even sometimes I start, quiet midnight shift, I'll click around and go, I didn't know they had that. So there's a lot of good stuff on here. This is a site run by the National Operational Hydrologic Remote Sensing Center, which is also a lot to say, so it's just called NORIS. And this is a site out of Minnesota, and they run snow modeling for the entire country. So they run models that say how much snow is on the ground and how much water is in that snow. This is updated once a day. So this is a good for in-between times when that cooperative snow survey by NEMA isn't being done. This is a good place to go. The only thing I caution is because it's being modeled by a computer, just use it with caution. It seems like to me they're always too high across the North Maine woods for snowpack, but for the most part, they're usually pretty good. And same kind of information that you can get from the cooperative survey. Snow depth, how much water is in that snow, is it above normal, is it below normal? How much snow have you lost in the past 24 hours or 48 hours, things like that. So it is a really good site to go to, at least get an overall idea of how things are looking. So what are some things that you can do as we're heading into spring and potentially getting close to breakup? What can you do? First of all, stay informed. Know what's going on. You can look at our website. You can look at the other websites that I've pointed you to. How many people here have or have heard of NOAA Weather Radio? Yay! I like lots of hands. So NOAA Weather Radio, as I don't have to tell you too much, is a 24/7, 365 weather broadcast that comes directly out of our office. These are the transmitters we have across the state, and usually it's just the current conditions and the forecast for the next 7 days, those kinds of things. But anytime we have any kind of product out, a watch, a warning, an advisory, it gets put on there. And the thing I like about NOAA Weather Radio, I live in a place, my house, I don't get good cell phone reception. So if I've got alerts set up on my phone, I can't get them when I'm at home because I don't get good reception. And weather radio though, that'll go off. If there's something going on in the middle of the night or that I need to know about, it'll go off. So it's a good way that I can stay informed on what's going on when I'm not at work. So there's also social media. We are on Facebook and Twitter. I always have to give Darren props because you guys did fantastic this spring on your Facebook page. And I know a lot of local police and fire departments have got Facebook or Twitter accounts. It's a great place to get information. I don't recommend it being your only source of information because when we're really busy, we can't update Facebook constantly. But we do try to get in there at least, maybe give you a forecast for the next few days or a heads up that something's coming. And it's also a good place, people put in reports of what's going on where they are, you know. Oh, I just had, 3 inches of rain, or the ice is moving out in Fort Kent, or it's a great place to get information. It really is.
It's helped us a lot reach out. We have almost 2,000 followers on our page now. Our website, we have a news feed there that we kind of have them tied together, so we can, with one post, we can hit both places for those that don't have Facebook. But Facebook allows us to back and forth a little better, and if somebody has a picture that they wanted to share with us, or they can show us the conditions, and they wanted to share it with the area, that's helpful. We were able to post quite a bit through this spring's issues. I only caution that we aren't looking to take over DOT's road information. We try to post disaster-related information with roads and whatnot. I did unfortunately get calls after, people asking me, well, is there a detour on this road for paving? And I have to redirect them back to DOT. I'm glad that people are following us, and we want more people to follow us. I mean, if you think about a web page or a Facebook page with just under 2,000 followers, it's pretty good. But if you think about the population of Aroostook County, it's really very poor. So we're not reaching everywhere we want to, but it is definitely a start for us.
Yeah. And we share a lot of your guys' stuff on our Facebook page, or they'll share stuff from us. It's just a great way that, you take 30 seconds to type something up and send it out, and they can potentially reach a lot of people, because they're having to individually call every person or something like that. So, it's not an end-all be-all where you should get information, but it's definitely, I check it when I'm at work just to see what's going on.
We are definitely trying to do more outreach, and that's the direction that I want my office to head. And I want to reach into areas that we possibly haven't reached out to very well in the past, and this is one of them. And so I'm really glad that we were able to come down in southern Aroostook. I think we need to do more in southern Aroostook. I will tell you that I've been trying to reach into southern Aroostook, but if I get nothing back, it makes it very difficult for me to put anything down. So I encourage people to tell me what you'd like to see and where you'd like to see it, because we'll do it. I'll come down. This is part of my county. I have no issues with coming to southern Aroostook. I just need to know what and where and what folks want.
And we're the same way too.
I think what's important is we need to know what you offer. You want to know what we want, but what do you offer? What can you provide for us versus what do we want of that?
Yeah, that's a really good question. We do post a lot of information on our website of what we do and what we can offer. I can't answer you in a couple of minutes. It's such a broad range. We cover so many different things, but we do try to keep really in close contact with the local EMA directors as well, so they get everything that we're doing. So, ring their bell a little bit. Ask them what's going on. Can we get more stuff down here? And encourage you to go through that. And certainly, seek us out.
So another good place to get information, of course, is television. We do have a good relationship with WAGM. And that's another, we look at their Facebook page too. We can put a call out for spotter, snowfall reports. Maybe we'll get 30 people. Ted Shapiro puts out a call for snowfall reports, and he gets like 100. So he's pretty popular. But WGM is a good place to get information too, and to get it out. And then, of course, radio. If you're going to get your information from radio, it needs to be local, not satellite. No Sirius or XM. So if you see something happening, and this isn't just for flooding, but you see an ice jam, you see trees knocked over, you see lightning hit a house, whatever. Obviously, you want to contact your local authorities. If it's an emergency, call 911. But you can always contact us. Sometimes we'll get calls from, Darren or something will let us know what's going on, or we'll get calls from Fort Kent Police or State Police or something like that. But a lot of times there's things that happen that we don't know about, that, we want to know. I mean, too much information isn't a real thing, so for us. So, and maybe we need to, we see a storm on radar, but we're not sure if it's producing any wind damage. But then, we get a call from Island Falls. I just had a tree get knocked down in my yard. And then we send out our warning. Ground truth is huge.
We're the same way. I'd rather get a piece of information 4 times than not get it at all.
Exactly.
So,
Exactly.
if you're just not sure, just shoot an email, or and we do a lot through technology.
Right. And if we can help you guys out too, because again, if there's a severe storm or a flood, and we never hear about it, it's not official. And then what if you try to make an insurance claim? And they said, a lot of times they'll come to us or come to official records looking for, yes, there was a severe storm in the area, or yes, there was a heavy rain in the area. But if it was never reported, we never heard about it, it doesn't get official. So
do the weather watcher phone calls come out of your office?
Weather watcher?
There was a course recently in Holton for become a weather watcher, and I occasionally get phone calls asking about our weather in town. I thought it was the National Weather Service.
Yeah, I think you're the weather spotter.
Yeah.
Yeah, we do have hold courses, usually through the summer, here and there, that to show you what to look for and what to report and those kinds of things. And yes, those go direct to our office. That 492-0180 extension 0, that goes right into our operations area. And there's always at least 2 people there. Every day, every night, days, help.
Usually every major storm, I get a phone call from you guys asking.
And that's what, a lot of times
Yeah.
if you get on our spotter database, if a storm goes over the area and we don't know for sure what's happened, we'll start making phone calls. So if you get a strange phone call, or we'll call, a lot of times we like to call town offices and those kinds of things too, because we know you're reliable. But, or like a town office or a post office, you might get people in and out through the day. So somebody might say, oh yeah, I saw lightning hit a house, or I saw water going across this road. That maybe you didn't physically see it, but maybe you've heard about it. So we do like to call town offices and post offices and police stations and those kinds of things. Because it's important for us to know, if we put out a warning and we don't get any storm reports, well, maybe that wasn't a good warning then. So we go back and, okay, why did we warn on it? Why shouldn't we have? So we learn from our mistakes. But ground truth is really, really important when it comes to learning from our mistakes. So the radar can only tell us so much. You might think the radar says it's snowing there, but we don't know for sure necessarily unless somebody lets us know. So, but the most important thing you can do during any kind of ice out, but any kind of weather situation is stay safe. That's the most important thing. And first and foremost, we always say obey all your safety or emergency personnel. They're not telling you to not go down that road because they want you to be late for work. They're not trying to make you miss your dentist appointment or whatever. They're just trying to keep you safe. They're just doing their job, trying to keep you safe. They may know something you don't. Maybe that dam down there is going to break. Or maybe the road's washed out and you just can't tell. Just be smart. You never want to drive around barricades. If you're ordered to evacuate, do so immediately. If you don't evacuate, not only are you putting yourself in danger, but anyone who then has to come rescue you when your house does flood or something like that, they're putting themselves in danger too.
We still have a lot of people that are driving around barricades, and we saw it a lot this spring. And we had one lady that in Fort Fairfield that drove around barricade and found out that there was no road where the road was. So the front end of her car went down into the ditch that was newly created, and then we had to send responders into that hazard zone to get her out. And we left the car there. She was not very happy with that. Said, "We're not risking the life for the car. We'll get it later."
Yep.
And Wrecker did go and get it out later, but folks just need to know those barricades are there for a reason.
Right. last year during Arkansas, they had some bad flash flooding, and a couple refused to evacuate their house, even though they've been told to do so. Well, their house flooded, so they called for help. A police officer and a wildlife ranger went to rescue them. All 4 people died because the house collapsed. It's not worth it. Just evacuate if you're told to do so. I mean, that's fantastic. You said people evacuate on their own. But just, it's not worth, you know, your home can be replaced, your possessions can be replaced. You cannot. And the people who may perish when they're trying to rescue you, they can't be replaced either. So to reiterate what Darren just said, our big thing is turn around, don't drown. Never drive down the road that is flooded or closed. Even if there's no barricade, if you see water across the road, don't drive across it. Of all flood fatalities, nearly 50% are vehicle related, and of these, 10% are people who drove around a barricade. You know, can't always tell how deep the water is. If you can't see the road surface underneath it, maybe there's a new ditch, maybe it's been damaged, maybe there's a bunch of debris, you don't know. You know, I understand. I mean, you know, maybe, it just, where I need to go is right there, I need to get past it. You know, I measure, one of the places I measure snow in the spring is Oxbow. And this past spring I went down to go measure snow at Oxbow, and 100 yards from where I measure snow, the road was flooded. And it was like 6 inches of water. And I was driving a Dodge pickup, I can make it across. And then I went, no. I can't see the road, I can't tell what it's like underneath that water. It's not worth it. The snow just doesn't get measured this week, not a big deal. So I turned around and went back.
We closed one portion of the road one time, and I was hoping that people would follow it, and they did. Luckily for this section of road, they didn't cross the barricade. But if you looked from your vehicle, you could see the road. You could see the water, you could see the road, and it looked like it was safe to pass. What you couldn't see until you got out and walked alongside of the road was while the pavement was there was no dirt underneath it. So there was actually a ditch underneath the road. The pavement appeared to be fine. So fortunately we didn't have anybody drive over, because it would have just collapsed under the weight of the car. It's, you know, you just can't tell.
And this goes for walking too. Unfortunately, this past spring we did have a gentleman who passed away. And when it was right near his home, he tried walking across a road that was flooded, and he stepped into a culvert that he didn't see, and he got washed downstream.
Isn't that almost in his driveway?
Yeah, I think it was. He was moving equipment or something, I think was the story.
He was trying to move his car out of the danger area.
Right, so, yes.
Okay, if I had 2 roads that were closed, as chief, I would like to know about these roads being closed, because it affects my response.
Yep.
Yep.
And I was never notified of the roads being closed or.
Yeah, I ran into similar issues this spring, Fred. And if you go onto the 511 Maine website, you can sign up there to have them send you updates. So if the supervisor at 2 a.m. decides he needs to close a road, they won't call you and wake you up. But if you have a smartphone, or if you check your email, you know, we know certain periods of time we need to really be vigilant with watching everything. Yeah, so they'll push it out automatically. To get them to call you, you might get a supervisor that says, yeah, I'll call you, but you'll only get the calls from that supervisor. It's really not a terrific system at this point. But if you sign up for those updates, so that as soon as they close something or open something, they'll shoot you a message, that does work, and they do it.
Is about Bancroft Road, as mentioned, non-market, game reserve, to Timon Bridge, was told I could not get past. So I had them for the company from their end.
Yeah.
And
As a chief, it's very frustrating because they don't give you what we think we need, but they don't look at the same issues that we do, and so they're not thinking about. Although in my mind, of course, I'm a little biased. I've been doing this 23 years. I think they should be thinking about a fire truck, but
yeah,
they're not, and so they'll post that they've closed the road, but
or if
they may or may not think to call you. I mean, you can contact your regional DOT office and ask for them to do that. And I don't discourage you from doing that, but you might get better, quicker information by signing up for that service. That's what I found this spring. I kind of struggled with that myself.
it's often embarrassing, it's also, hey, do you know this road is closed? I'm like, no, I didn't know.
Yeah. Yeah, even at my level, I find the same issues that my county EMA has. When I'm putting that on, I still struggle with getting that information, and it is embarrassing to me too when my county commissioners call me and ask me about closures that I didn't know about, so I understand.
Right? Obviously, you always want to stay away from floodwaters or ice jams. Stay away and stay alive. As we saw from that video, water levels can rise very, very quickly. So some of those hydrographs we looked at, we're talking 5, 10, 15 feet in just a matter of minutes. Don't want to go near ice jams. It's kind of human nature to want to go out and look at something like that because it's really cool, but you don't want to do it. Or if you're going to do it from well far away. Do not climb out on an ice jam. They had problems with that up in St. Francis this past spring.
I had
out walking
a
around
bunch of teenagers that were trying to surf the ice flows down the St. John River. I was very fortunate that there was some state police and sheriff's units not that far away, so they were able to take care of that quickly, but it could have gotten really bad really fast, and there is no rescue from that.
And even if it looks like it's solid, one piece of ice, you step on it and it flips over, you're done. You're in that cold water, and that's it. Again, it's not worth it. It's not, you know.
We have an issue with snow slides crossing. It would be frozen on one side and frozen on the other, and they'll just gun it. And it's right before the dam, so we've talked to these individuals about it, but what do you do?
No.
Yeah. Beyond talking to them, the only other thing you can do is talk with the warden service if there's any open water. They can be cited for that, but they still do it. I have 4 lakes in my fire department coverage area, and I have people that skim. Yeah, yeah. They see the open water and they say, "Oh, for years sleds have skimmed," you know. And we're still seeing it on Facebook. It's crazy.
Yeah, I live, my house, I overlooked the Aroostook River, and of course there's snow slots going up and down there all the time. And we'll get into spring and we'll see there'll be open spots, and they're just flying down in the middle of the night. It's dark.
Yeah.
It's like, sure hope you don't have to call the police or somebody.
We were doing a flyover, was it last year? You were with us.
It was this past spring.
When we came up on the sledder.
Yep.
And so we got the pilots turn around and go a little lower, and he kind of followed the sledder. So he kind of freaked him out, so he jumped off the water and went in the woods.
Oh no, that wasn't it. I don't think I was with you.
You weren't with that?
Not that time. We did go over snow sleds once, but I think you or Jesse told me that story or something. So there was
Yeah,
open
it
water.
was in Cross
There was
Lake.
open water ahead or something,
It
right?
was in Cross Lake. We were seeing the open water, so we turned around so we could watch. So if he fell in, then we'd at least be able to give some coordinates and get some help. And he was freaked out by the helicopter over him, so he decided to get off the lake, which worked for us. We just wanted him off of there.
So yeah, ice jams just by nature are very unpredictable. So you just don't want to put your life in danger. People have lost their lives. In '94, a couple of customs agents were killed when an ice channel released. So the neighbors out doing their job, trying to keep their citizens safe. So, and that is the conclusion of my presentation. Any questions, any comments? And it doesn't have to be related to river ice. Any questions about the weather service in general, or the weather in general?
There's a phenomenon that's been going on around on the internet. It's the ice discs.
Yes.
Okay. I have this. I actually live on Fish Stream,
Okay.
and we had this happen last year. What is the cause of that, and what can that tell us about what's going on?
It has to do with, my guess is when that happens, there's probably a natural eddy there.
Mm-hmm. Yeah.
And so that frazzle ice just constantly collects on that pan, and then it gets to be so big, and the rest of the ice just gets kind of moved downstream. So it could be that that's maybe, you've got a little bit maybe higher flow, I guess. I would think that maybe it happens a little bit higher flow when you've got enough turbulence that it's going to sit there and spin. Maybe if it's not a real fast flow, maybe something's just more likely to just move downstream. But I've actually never seen it myself, so that's got to be really cool to see. Be neat.
The folks online wanted me to thank you for
Anything
this
else?
on.
Is
Questions?
there any handouts or anything that has some of the information that you guys presented today?
I don't have any handouts. That's the one thing I should have done for these.
We don't, I was just talking, very fortunate that my new deputy director is an IT guy. And so I was talking to him yesterday about posting this video up on our website so that folks could still get the information. So we're going to try to make that kind of stuff happen. And we're also going to offer it out to those local access channels. Does Isle Falls have it?
I believe it was.
They don't. So for those that do, we're going to try to allow them to put it out. But for everybody else, we can at least put it online so folks can.
We have a Facebook page that we could probably post it on. If you post it on your Facebook.
Okay. You run the Isle Falls one?
Yeah.
Good.
All right. Thanks, everyone.
Thank you for coming out. This is very helpful.
Try to see if I can find a picture of that really quick. So I have a look. Oh, here it is. Yeah, this was actually